Either. Okay, good afternoon on site and good afternoon online. All right. Okay, so we still have to continue with the trigonometric functions, trigonometric ratio that we have been discussing, starting from tangent, sine, and today we will have cosine. Okay, now not COVID. And okay, remember we have the abbreviation or the shortcut way to which we can remember the formula or the trigonometric ratio, the SOHCAHTOA. Okay, so means sine opposite over hypotenuse, ka means cosine adjacent over hypotenuse, and tangent tua opposite over adjacent. Okay, so just remember that one. Whatever you do, the topic will still, or the formula will still be the same. Okay. Now, again, today we will continue on the third trigonometric ratio, which is all about cosine. Okay, so online, please follow. We will discuss a little bit and then we will have the activity. Okay, we will do the activity as fast as we can so that we can finish all. You don't have any more homework and you don't have any more tasks to do. Okay, on site, a little bit silence, please. Okay, may I request before I proceed, may I request online to please turn on your camera? Online. Otto, P, Tang?
Yes.
Okay. And you have Dean and Kaimu. Please turn on your camera for purposes of checking. All right, guys, turn it on for purposes of checking. Okay, why is it a dog? Oh, it's a cat. Okay. So we will now continue. Can you now see on your screen? Guys online, can you see now your screen? Okay. Can you see? Kaimu, Ota, did you see?
Yes.
Okay, okay. So I will share it again.
I don't see.
Okay, okay. I'm making it sure because you did not respond when I asked. Okay, so we continue with cosine. All right. Now, cosine is a trigonometric function referring to the ratio of a right triangle. Now, recall the parts of a triangle. Remember, you have the hypotenuse, which is the longest side. Okay, the longest side is the hypotenuse, opposite with regards to the given unknown angle theta. Opposite to that one, okay, and we have also the adjacent. So always remember that we base the opposite and the adjacent according to where the unknown angle is. And hypotenuse is always the longest side. Okay, now. Okay, remember the key there is the theta. It is where your opposite and adjacent will matter to the given theta. Okay, so what is now what we call as the cosine function? Okay, and if we have it, we call that one as cos for cosine, sin for sine, and tan for tangent. Okay, remember that cosine theta is the adjacent side of a right angled triangle over the hypotenuse with regards to the given angle or a known angle theta. So again, always base your the sides according to the angle. So opposite to theta is this side, all right? And adjacent to, adjacent means from the side, okay? So this is the side, adjacent to that one is this side. And hypotenuse is always the longest side in a triangle. So when we are to get cosine of the angle theta, we use adjacent over the hypotenuse. So that means we do not get the opposite. Again, cosine theta is adjacent over hypotenuse, always. Now, as we continue, all right, here, we take this triangle, right triangle, as our example. Okay. So, cosine of theta refers to the adjacent side over the hypotenuse. So as you can see, always, remember, if this is your theta, adjacent side is this one, hypotenuse is always this. Now, if your theta is in this side, so this is the unknown angle. So your adjacent side is this one, and opposite side is this one. So what matters is where your theta is. So in here, adjacent side is this one. If in here, adjacent side is this one, and opposite side is one. Okay? So, and remember, hypotenuse is always fixed, opposite to the 90-degree angle. Okay, so that means that your opposite and adjacent side will change depending on where your theta is. Okay, so again, it matters where your theta is located. The adjacent and the opposite side will change if the theta will change also. Okay, so online, with regards to the unknown angle theta, if this is your theta, then the adjacent side is this one. And the hypotenuse is always opposite to the 90 degrees. Now, if your theta is here, all right, so this is your unknown angle. So the opposite side is this one, and the adjacent now here, this now becomes the adjacent side. Okay? Now take note that it will matter where your theta is. If in here, adjacent is this side. But if your theta is here, so adjacent is this one. All right? And of course, if this is adjacent, then the opposite side is that one. Okay? Now again, then again. If your theta is here, all right, adjacent side is this one. Always remember and do not get lost. Okay? And of course, your opposite side is this one. If, again, your theta is this angle. All right? So do not confuse. Just refer where your theta is, so that you can tell the adjacent, the opposite, and the hypotenuse. Next. Okay. Given this example on your screen, and we said that cosine of theta equals adjacent over hypotenuse. Given that your angle theta is here, so therefore, cosine equals adjacent over hypotenuse. Or adjacent side is 6 and hypotenuse is 10. Okay, so again, your theta is here. So therefore, adjacent side is 6 and hypotenuse is 10. Now, what is then the ratio or the cosine theta? Take note, we can reduce this one to lowest term. So therefore, our final answer will be cosine theta equals 3/5. Again, this is now your final ratio, 10/5. 3/5. When we reduce this one to lowest term. So 6/2 is 3, 10/2 is 5. So cosine theta with that triangle is 3/5. Okay, now remember, reduce your ratio to the lowest term. Okay. All right, so do not confuse yourself with that one. Next, the cosine. All right, on site, please read. In 3, 2, 1, read. The cosine proportionally. Okay. Now, what does it mean? The cosine of an angle is equal or does not change when your angle change or your triangle change proportionally. Okay, proportionally is in the same ratio. Okay, taking this example, how many triangles can you see on that example? How many triangles? 3. Okay, so we have triangle A, B, and C. Okay, now we said that cosine theta equals equals K adjacent over hypotenuse. Now, in the example, all right, adjacent is 12 and opposite is 13. So that is why we have this cosine of the first triangle ABC 12/13. Okay, now cosine of the second triangle. So from here to here and from here to here. So therefore, you have now cosine theta equals adjacent 12 plus 12 over hypotenuse 13 plus 13. So that your cosine of the second triangle ADE equals 12 plus 12, 24/26. Now, if we reduce to lowest term, it is still the same, 12/13. All right. Triangle AFG, the biggest triangle. So therefore, you have now here and of course here. So cosine of theta, take note your theta is here. All right. Your theta is here. Cosine theta equals adjacent. So 12 plus 12 plus 12 equals 36 over 13 plus 13 plus 13 is 39. So 36/39 reduced to lowest term, it is still 12/13. So then, as you can see, 12/13, 12/13, 12/13. So theta or the cosine of the triangle does not change. The cosine of the angle does not change, even if our triangle gets bigger, as long as it grows proportionally. Same rate. So 5, 10, 15, okay, 20. So therefore, you add another 13. So cosine does not change if the triangle changes proportionally. Okay. Now next is finding the length given the cosine value. Okay, so finding the length given the cosine value. Okay. Online, please read the problem. Online, Otto, Pan, Dean, and the others, Taimuk, and the others, P. All right?
Yes.
Mute and read in 3, 2, 1, read. The cosine
Cosine of x of the line
Of the line
triangle is
angle is
0.5
5
by the length of PQ.
Okay, so you are given the cosine of x, which is 3.5. So therefore, x, this one, the given cosine here is 0.5. Okay. With regards to this angle, so the adjacent side given is 4 centimeter. Now, therefore, you are asked for the, okay, you are asked for the length of PQ. Okay, you know cosine of x and you know the adjacent side. All right, so how to solve the length of PQ? All right, we said that cosine equals adjacent over hypotenuse. But your hypotenuse is unknown. So cosine of x means cosine is 0.5 equals side adjacent. Adjacent side is 4 over hypotenuse PQ. All right, all right. So this one is side PR and this one is side PQ. Okay. All right. Now, since your PQ is unknown, so we can now use the cross multiplication method so that we can set the ratio and get the value of your unknown PQ. Okay. Now, so therefore, it will be PQ equals 4 over 0.5. And if you divide that one, that is just, oh, all right, all right. Okay, that is equivalent to 8 centimeter. Okay, so therefore, your hypotenuse there is 8 cm. Okay, so get now the idea how to get the cosine or the ratio of a right angled triangle given the unknown angle theta. Now, let us try to apply this one in our workbook, okay? So I need you to open your workbook online, open your workbook, and we will answer it as fast as we can so that we will be able to finish and you don't have any more things to do when we are done. Okay, so please open your workbook to page 90. 90. And we will answer it as fast as we can. All right, guys, online, let me see your workbook. P, Kaimu, Otto, Pawan. Pawan is online. Pang, Dean, and Prao. Let me see your workbook. I need to see your workbook. Okay, thank you, Otto. P, where is your workbook? Pang, Tin. Okay, Mook. All right, so Proud is present. Oppo not here. Okay, Pawan is present. Okay. Yes.
And I think notebook at school.
Okay, okay. Your workbook is here. Okay. All right. So page 90, we will do that one. All right, guys. Page 90. Page 90. And the date of today is Friday, 11/2022. All right. All right. Please follow, guys. On site, please follow. Exercise 8.3, number 1. All right. Determine cosine theta as a ratio of the sides in the following triangles. All right. Letter A. Cosine theta equals adjacent over hypotenuse. Okay. Ton, what is the adjacent side? Letter A, number 1. Adjacent. AB over hypotenuse. Where is your hypotenuse? Adjacent over hypotenuse. BC. Okay. All right. So you have now there. Okay. Letter B. Cosine theta equals, what is the hypotenuse? Bas? Letter B. You have no book? Okay. Letter B. Cosine theta equals adjacent over hypotenuse. Now, what is the adjacent? Letter B. Side. That is triangle M and O. Okay. All right. So that is in O or ON over hypotenuse is MO or OM. Right? So that's very easy. Number 2, so that we can finish this one, we will do it. Letter A. Find the values of cosine theta in each of the triangles. So cosine theta equals adjacent over hypotenuse. Now, letter A. What is the adjacent side, Alex? Letter A, number 2. Adjacent is 10 or 13? 10 over what, 20? Okay, 13. Right? Letter B. Cosine of theta equals kauklong. Kauklong. Cosine theta equals 8 over. All right, 8 over 10 equals Lewis term. Equals kauklong 4 over 5. All right, so that is correct. 4 over 5. Okay, number 3. Letter C. All right. Letter C, Kung Fu. Cosine theta equals. Letter C, cosine theta equals. What is the hypotenuse? All right, hypotenuse is unknown. So therefore, we use the Pythagoras theorem. And we know that Pythagoras theorem is c squared equals a squared plus b squared. Now, c equals the square root of a squared plus b squared. So 5 squared is 25. All right, so you have there 25 and 12 squared is 144. 144 plus all right, 144 plus 25 is square root of 169 equals 13. All right.
13.
Okay. So therefore you have now the hypotenuse. So cosine theta equals 12 over 13. All right. So that is now letter C. Okay. Letter D. Letter D. Oh, the same. You don't know the hypotenuse. So we use the Pythagoras theorem. So cosine theta equals, we don't know yet, but we need to solve for the hypotenuse. So letter D, C equals square root of 8 square is 8 square, 60. 8 square, 8 times 8 is 64 plus 15 square. Huh?
225.
All right, 225. So C equals the square root of
289.
289. Okay, so what is that one? Equals
17. 17.
All right, so you now have this hypotenuse 17. Now, cosine of theta equals adjacent side, which is 15 over the hypotenuse 17. Okay, so that is letter D. Letter E. Okay, we still have time. Letter E. Cosine of theta equals, no, it's not 40. 40 is the opposite side. So therefore, we solve for the value of one side. Okay, so cosine theta equals, we don't know the adjacent side. So therefore, the value of A equals square root of C squared minus B squared. So what is the hypotenuse? 41 square. So 41 square minus 40 square. Okay. So that is equivalent to the square root of, what is 41 square? 1,600? 1181 minus 1,600. Okay, so therefore your A equals square root of 81 or 9. So therefore you have now adjacent is 9 over hypotenuse 41. All right. Okay, so make sure online that you follow. Number 3. Okay, we use red so that will not. Okay. Number 3, A. Find the value of x in each of the following triangles with the given values of cosine theta. So letter A, cosine is 2/5. So cosine theta, cosine is 2/5 equals adjacent side is x/15. All right, adjacent side is x/hypotenuse 15. So you have there 5x equals 30 and x equals 6. All right, so 6 unit cm. Letter B. Okay, how many minutes? We still have 4 minutes. Cosine theta is 12/13. So cosine is 12/13 equals adjacent side is 24. So you don't know the hypotenuse. 24/hypotenuse x. Okay, so you have there 12 times x is 12x. 13 times 24. Alex, 13 times 24. 13 times 24. 300. All right, 312. So x equals 312 divided by 12. Okay, so x equals 26 cm. Okay, we still have 3 minutes. So letter C. Cosine is 15/17. You find the adjacent side. But you don't know also the opposite side. So therefore, we need to use the Pythagoras theorem. Okay. So to get the length of the adjacent side, 51 square minus 45 square. Okay, so adjacent side B equals the square root of 51 square is 2601. Okay, so 2601 minus 2025. Okay, so B equals square root of 576, or that is equals to square root of 576, which is equals to 24. All right. So we have 2 minutes more. So to get the value of x, use the cosine. All right, the cosine given is 15/17. Okay, equals the adjacent side is x over the hypotenuse 51. All right, so you have now 7x. All right, equals. All right, 1 minute more. This is letter C. Okay. Not 7, that's 17. All right, this is 17. All right, 17x equals 765. Or x equals to 45 cm. Okay, so you can solve now letter D and E because we don't have much time. So solve D and E. Yes. Sorry, that is Again, online you solve D and E. Okay, so again, this is not cm but All right, guys, online, you only do 2 numbers.